Okay, gentlemen, we are going to review day one of mean absolute deviation. As I normally do, I am going to put the link for the Khan Academy video that we actually saw today in class in the description box, so please feel free to use it. So looking at our key takeaways, I just want to first review the two really critical definitions that we talked about today. And the first one was clustered data. And clustered data has low variability and the values tend to be close to the mean. And an example we talked about today of clustered data would be if I were to ask the ages of all of the boys in 7th grade, that would probably be clustered data because most of you are probably between the ages of 11 and 14 years old. So I'm not going to have a lot of variability in the ages. But if I were to ask the teachers on staff their age, we might have more spread out data. Which has high variability. And the values can be further from the mean. Now, if I were to take a sample of the ages of the teachers on staff, there would be more variability. Some teachers, like myself, have been teaching forever and ever and are older than perhaps I'd like to admit. And while we have some teachers on staff that are a bit younger, who are new in their teaching career. So we would find a variability because the range of the staff ages is probably somewhere around 15 to 20 years. So that would be an example of spread out data. And we'll take a look here and review some of the work that we did today. And I'm actually going to skip down to the guided practice because the guided practice is like not so different from the page before it. So we have Mr. Loriot, and if we remember, he took his kids on a field trip to the Empire State Building, and he stayed on the 77th floor. And the average that all of the students were on, Amir, Dalbert, David, Catania, and Dante, when we added all of these numbers up and we divided them, we got the mean of this data was 77. So the mean of this data is equal to 77. Okay, so the mean is the 77th floor. But now I am looking for the mean absolute deviation. And so what I need to do is I need to go to each point of data and I need to see how far away that point is from the mean. So for example, if Amir is on the 128th floor, he is 51 floors away from 77. If Dalbert is on the 20th floor, he is 57 floors away from the 77. David is on the 35th floor. He is 42 floors away from 77. Catania is on the 82nd floor. That is 5 floors away from 77. And Dante is on the 120th floor. That is 43 floors away from 77. And now I want to actually review this term. When we say absolute deviation, what we mean is the absolute value of the distance from the mean. So it doesn't matter if you're below 77 or above 77, you're going to still have the absolute value, which is going to be positive. Okay, so now what I'm going to do is I'm going to find the mean of these absolute deviations. So I'm going to add together 51 plus 57 plus 42 plus 5 plus 43. And I'm going to, when I add that together, I'm going to divide it all by the number of data points, which is 1, 2, 3, 4, 5. Okay, I'm going to divide that all by 5. So when I add those together, I get 198. When I divide that by 5, I get my mean absolute deviation, which is 39.6. This is my mean absolute deviation, or the MAD. Okay, so what does this mean absolute deviation tell us? Well, when I'm thinking back to the idea of a clustered data set as opposed to a spread out data set, I know that if I have a mean absolute deviation of 39, which means that the average data point is 39 places away from my mean, this is a spread out data set. And what does that mean in terms of this particular problem? It means that the students are on a large range of floors. Okay, they are spread out amongst the different floors of the Empire State Building. Okay. All right, let's take a look at Mrs. Smith's group. So over here with Mrs. Smith, we also had a mean of 77. Okay, so these two sets of data have the same mean. And when I look at the distance, so from the floor to the mean, also known as the absolute deviation. The absolute deviation. Oh, I spelled that wrong. Okay. The absolute deviation from 77 to 78 is 1. From 77 to 71 is 6. They're 6 floors away from the mean. 79th floor is 2 floors away from the mean. Maya is on the mean floor. There's no deviation there at all, 0. Okay, so I'm going to take these numbers, I'm going to add them together. 1 plus 6 plus 2 plus 0 plus 3, divide them by 5. Okay, and that's going to give me 12 divided by 5, which is an absolute deviation of 2.4, mean absolute deviation of 2.4. So what does this tell us? And I can even kind of look at this data and it's clear to me. These folks are not so spread out. This is a clustered data set. So let's move down. This is a clustered data set. And so it's most kids in this set are near the 77th floor, which is our mean. And that's our mean, remember. Okay. Great, we're going to take a moment and look at the homework together. Exit ticket you did. Okay, homework. All right, so the table below shows data about the lengths of a random sample of comedy and drama films. Lengths for random sample of comedy and drama films. The table below shows the running time in minutes for comedy movies. So I have these comedy movies. I have 90, 95, 88, 92, 95. All right, so this table is showing me the running time in minutes for drama movies. I have 70, 112, 92, 97, 87. Okay, so I'm just kind of looking at this. I'm gonna sort of make a guess that my mean absolute deviation for the drama films is going to be bigger. And I haven't done the math yet, and I could end up being wrong, but I'm looking and there's a 70-minute film and there's a 112-minute film. And then the rest of them are kind of all around the 90s and late 80s. But if I look at the comedy films, really, they're all pretty much within the same 10 minutes as far as the length of their timing goes. So I'm going to go ahead and calculate the mean. Okay, so in order to calculate the mean, I'm going to go 90 plus 95 plus 88 plus 92 plus 95. And that's 1, 2, 3, 4, 5 pieces of data. So I'll put that over 5. And because I recommend that you can use a calculator when you're at home, don't worry about that. 5 plus 88 plus 92 plus 95. So I got 460 over 5. So if I divide 460 by 5, I get my mean of 92. That's my mean. All right. And let's find the mean over here while we're at it. I have 70 plus 112 plus 92 plus 97 plus 87, also divided by 5. Plug that into my calculator. 70 plus 112 plus 92 plus 97 plus 87 is going to give me 458. If I divide that by 5, I get 91.6. All right, so 458 divided by 5 gives me a mean of 91.6. So these means are very similar to each other. But now what we need to do is we need to find the mean absolute, deviation. Okay, so actually we need to see the values here. Bear with me, gentlemen. I'm coming down with a little bit of a cold. All right, let's go back to blue. So if my mean here is 92, I want to find the difference between 90 and 92, so that gives me 2. 95 and 92, 2 plus 3. The difference between 88 and 92 is 4. 92 and 92 is going to be 0. And the difference between 95 and 92 is 3. And I'm going to add them all together and divide them by 5. So I have 2 and 3 is 5, 9, 10, 11, 12. I have 12 divided by 5, which gives me a mean absolute deviation of 2.4. Okay. So what I can say is, looking at these comedy movies, their mean was 92, and there wasn't much variability because the average distance from the mean, so the average distance of each data point from the mean, was only 2.4 minutes. Okay, so let's go over here and take a look at our drama films, all right? And I'm going to find the difference between, and I'm going to, for the sake of not driving myself crazy right now, I'm going to round this up to 92. So we're going to round this, the mean is about equal to 92, okay? So the difference between 70 and 92 is 22, plus the difference between 112 and 92, is 20. We do have that one 92-minute. The difference between 97 and 92 is 5. And the difference between 87 and 92 is also 5. Let's draw a little line here, okay? So I have these all together. I'm going to divide them by 5. Let me make this just a bit neater. Okay. So that's going to leave me with 20 plus 22, so that's 42 plus 0 plus 5 plus 5. So it's going to give me 52 over 5. Okay, and so when I plug that in, that is going to give me a mean absolute deviation of 10.4. That equals 10.4. So it seems as if my original guess was correct, and that the mean absolute deviation between a drama film and a comedy film in this study tended to be longer. So the more variable set of data is the drama film data. All right, so I'll write that here. So this is clustered, and this is spread out. Okay, so what do the differences in the mean absolute deviation tell us about the length of comedy movies compared to that of dramas? Okay, so from this information, what I would say is that comedy movies are mostly around 90 minutes long, while drama movies have more variation in their timing. Okay, so that is our mean absolute deviation, day 1. Good luck with your homework tonight, gentlemen, and I will see you tomorrow.